For centuries, ancient alchemists dedicated their lives to a dream to turn ordinary metals into gold. They mixed strange powders and heated bubbling cauldrons, hoping that one day they would discover how to create the world's most precious metal. But despite their tireless efforts, gold remained stubbornly out of reach. Little did they know, the secret to its creation wasn't hidden in their laboratories, it remained dearly in the stars. Yes, stars are the true alchemists of the universe. Made mostly of hydrogen, the simplest element, they are like colossal mines. Gravity pulls these hydrogen atoms together with such force that they fuse, releasing a brilliant burst of light and heat. That's what makes stars shine so beautifully in the night sky. As stars grow older, they transform hydrogen into heavy elements like helium, carbon, and oxygen. This nuclear fusion happens faster and faster, burning through elements one by one until the star is filled with iron and nickel. But when a massive star reaches its final days, it can no longer hold itself up. The core collapses under its own weight, triggering one of the most powerful explosions in the universe, a supernova. During this incredible blast, temperatures and pressures soar to unimaginable levels. Protons and electrons slam together, forming neutrons in a process called neutron capture. At that very moment, simple iron atoms begin absorbing these neutrons, turning into entirely new elements. Among them is the glittering gold that humans would one day mine from the depths of the earth. When the supernova explodes, it scatters its treasures across the universe, like a gardener planting seeds. These elements drift through space, mingling with clouds of dust and gas, eventually becoming part of new stars, planets, and yes, even our Earth. That's how gold found its way into the cracks and crevices of our planet's crust, waiting patiently for us to discover it. To bring gold to the surface, humans dig deep into the earth through mining. Massive machines unearth rocks containing traces of gold, which are then crushed, ground, and treated with chemicals to separate the precious metals from the surrounding stone. Finally, the gold is melted down to remove impurities, emerging as gleaming bars or coins. It's a tiring and rather process, which is why gold is so valuable, not just for its beauty, but for the sheer effort it takes to extract. But what if we want more gold? One idea is to create it ourselves using particle accelerators, gigantic machines that smash tiny particles together at mind-boggling speeds. In theory, this mimics what happens in stars, forming new elements like gold. The catch? It's incredibly slow and expensive. Producing 1 gram of gold this way would take longer than the age of the universe. Another idea is to look to the oceans. Believe it or not, the sea holds around 20 million tons of dissolved gold. But it's so diluted that retrieving it would cost far more than the gold itself. Perhaps the real answer is to search for gold where it all began, in space.